Hello, and welcome back to Gluten. What is Hadoop and what can it do? Let's take a look. Hadoop is an open source framework that is used to store and process large data sets. The amount of data has skyrockets from gigabytes to zettabytes, and we need a better way to store and deal with all that information. That's why Hadoop has become a big deal in the data world. It's now one of the heavy hitters in the industry. Hadoop consists of four main modules: HDFS, Yarn, MapReduce, Hadoop Common. HDFS is used for storing data, and MapReduce is used for processing data. What is HDFS? HDFS stands for Hadoop Distributed File System. HDFS operates as a distributed file system designed to run on the standard or low-end hardware. Before we dive into HDFS, let's take a step back and learn what DFS is. DFS stands for Distributed File System. File system, just like your local computer, such as PC and Mac, it stores files and data. The main difference from local file system is that instead of storing data in one single machine, it stores data in a cluster. Even though data is stored in multiple machines, the DFS will organize and manage the data like just one single local storage unit when you are accessing from anywhere. For example, two machines with 1 GB storage in the DFS cluster can act like a 2 GB storage unit. But why do we want to choose a cluster of machines instead of one single machine? Isn't one single machine easier to manage? Why do we need a distributed file system as local file system can also serve data? There are a couple advantages that a local file system cannot do in the first place. Performance. One read can take one machine 10 minutes to process. However, with a cluster of machines, it can take 10 machines to process in just 1 minute, since DFS can handle traffic in parallel. Scalability. To scale a local file system, what you can do is to add more memory. However, this can be costly because you will need a high-end computer hardware. To scale a DFS, you only need to add one machine into the cluster network to scale horizontally. In terms of availability, a local file system also serves as a single point of failure. If your server is down, then there is no way to access your data until it comes back up. DFS replicates your data to multiple nodes, and by having multiple nodes access the same data, the risk of data loss due to node failure is reduced, because other nodes can also serve data. This increases the overall availability of the data and reduces downtime. We talked about DFS and its benefits. Let's dive right into HDFS architecture. HDFS has a master failure architecture. An HDFS cluster consists of one single name node and a number of data nodes. Name node is a key component in the HDFS. It is responsible for managing the file system metadata in the cluster, such as the location of files and blocks within the cluster, and the status of data nodes that stores the data. The name node also coordinates access to the data stored in the cluster, ensuring that multiple clients can access the data simultaneously and that data remains consistent and up to date. Essentially, the name node acts as a brain of the HDFS cluster, provide a central point of control and coordination for the entire system. On the other hand, data node is responsible for storing and serving the actual data in the HDFS cluster. The data nodes run on individual machines within the cluster and are responsible for managing the storage and retrieval of the data stored in the HDFS. When a client wants to read a file stored in the HDFS, the name node directs the client to the data nodes that stores the data. The data node retrieves the data from its local storage and sends it back to the client. When a client wants to write data to the HDFS, the name node also directs the client to the data nodes for the data to be stored. In HDFS, data is stored in a distributed manner across multiple data nodes in the cluster. When a client writes a file to the HDFS, the file is split into one or more blocks, and each block is stored on a different data nodes. To ensure data reliability and availability, HDFS replicates each block of data multiple times and store that replica on different data nodes within the cluster. This is called data replication. By default, HDFS replicates each block 3 times. This means that 3 copies of the same block of data are stored on 3 different data nodes. This ensures even one data node is down, the other data node can still serve requests. In case a data node fails or becomes unavailable, the name node detects the failure and initiates the process of replicating the data stored in the fail node to another node in the cluster. This ensures that data remains available even the hardware failure or other disruption. Data node replication in HDFS is a critical component of the file system that ensures availability of the data stored in the cluster. Let's take a look on how name node manages cluster when one data node is down. The data node communicates with the name node to send information about the state of their storage, including the amount of disk space used and the status of individual data blocks. This information is used by name node to keep track of the health and status of the cluster to balance the data node in each node. The name node processes data node heartbeats in the following way. First, the data node in the HDFS cluster sends heartbeat periodically to the name node to indicate that they are active. Second, the name node processes these heartbeats, using them to keep track of the health and the status of each data node in the cluster. If a data node fails to send a heartbeat within a specific time period, the name node assumes that the data node is down and marks it as dead. If a data node is marked as inactive, the name node starts the process of replicating the data stored on that data node to another node in the cluster to ensure data availability and reliability. While HDFS is designed to ensure the reliability of the data stored in the cluster, it does have some limitations and downsides that we must consider. One of the main limitations of HDFS is performance in terms of read and write speed. HDFS is optimized for batch processing and large-scale data processing, but it can be slow for small files and random access patterns. Another limitation of HDFS is scalability. HDFS is designed to scale out by adding more nodes to the cluster, but this requires manual intervention and can become complex in large deployment. Additionally, HDFS does not provide real-time data processing capability. While it is designed for batch processing, real-time data processing is become increasingly important in many applications, and HDFS may not be the best solution for these scenarios. To conclude, while HDFS provides reliability for data stored in the cluster, its performance, scalability, real-time processing capability must be evaluated while deciding if HDFS is the right solution for a given use case. Hey, if you like this video, please like and subscribe. Thank you.